Oh yeah, my name is David Wells. I work at a startup in town called Serverless. How many people in the room have like done anything with AWS Lambda or anything serverless? Okay, got some people. Cool. How many people have used Serverless, the framework, CLI tool? Okay, cool. So a couple people. Awesome. So where is the clicker? That would be helpful. I can over there. Okay, 1 second. All right, so I'm here today to talk how like basically DevOps fits into the serverless world. How do I turn? Okay, that's not working. All right, we'll do it the old-fashioned way. So yeah, I'm here today to talk about serverless, how that fits into the DevOps world. Basically, DevOps, we all know and love, it has to do with all these things, right? How do I package up my code? How do I build it? How do I test it? How do I release it? Configuration, monitoring, security, and then a slew of other things that I need to worry about. It's very similar in the serverless space. There are some differences, and we're going to go through these quickly. It's also, as people might know, kind of a state of mind and a culture that you kind of embed in your company. If you don't like fully grasp it, things kind of tend to break down. But what is serverless real quickly? Serverless can be described in this one slide. And basically, this is what people say when they hear the word serverless. They say, but there's got to be servers somewhere. Of course there are. That's not the point. The point is that you no longer have to manage them. You no longer have to patch them for security. You no longer have to scale them. All that stuff is abstracted away from the developers. And basically, serverless infrastructure kind of has these qualities. So it's code that you run on demand in a cloud of your choice with pay-per-execution pricing. You never pay for idle. It auto-scales for you. And there's this idea of event-driven workflows, which we'll look at in a second, as well as leveraging third-party services like a Twilio or some sort of transactional email service, because that's not your company's core competency at the end of the day. And like I mentioned, it can run in a cloud of your choice. So all the major players, as described earlier, Microsoft, Amazon, Google, IBM, as well as Oracle, as well as some spot pricing players out there, one called Spotinst in town. You can run your functions anywhere, right? It's or in your own Kubernetes cluster, or in your own Docker form. So it really, is up to you where you want to run your functions. Doesn't really matter, but they all have those same characteristics of never paying for idle, which can have some like considerable cost kind of benefits. This is right now the current adoption cycle, in my opinion, of where we are in the serverless world. We're about right here. So there are a lot of Fortune 500 companies adopting serverless in production today. I have like a ton of other presentations like about that. I'll share some links at the end. But we're about there. The adoption curve is slowly picking up, or quickly picking up. Some use cases real quick. There's so many to go through. Like it's really up to your imagination of what you can run inside of a serverless function, with the one caveat being if the thing needs to run longer than 5 minutes, that really doesn't fit in the functions as a service space right now. There are ways to kind of get around that. It's a little hacky and not recommended. But yeah, so if you have longer running jobs, you're still going to need a server. But if you, any of these others, back-end web APIs, data, pipeline, transforms, analytics, processing. What we're going to be talking about mostly today is DevOps automation and infrastructure automation. But yeah, tons and tons of use cases out there. And that link at the bottom is like a list of other examples. Cool. And then back to the kind of event-driven side of it. So this is like the AWS ecosystem, or at least some of the services, like probably 5% of the services they actually offer. But all of these can trigger your Lambda functions. So not only is your code running from actual like requests over the wire, but they can actually be triggered directly from infrastructure events. So an example of that would be like an object is added into an S3 bucket that can then trigger a function to then process it and do something with it. Or we'll dive into this a little bit more, but you can listen to different CloudWatch events. So if someone provisions an EC2 instance that doesn't meet your company's security requirements, you can automatically trigger a Lambda function to shut that down or to update the IAM policies around that to make sure that your compliance is in order. So serverless DevOps, we're going to run through these pieces. There's a lot, so we're going to go kind of fast. The first one is code. So code, you write your code as usual. The only difference is at the very top layer, you have to basically match whatever provider you're using, the function signature. This is an example of Node code, but almost every language is supported, or you can shim it depending on the provider that you used. I have a soft spot in my heart for Node, so I use Node for everything. But Lambda just announced Go, which I believe will be the darling child of the serverless world very soon. So your code, you write your code as usual. You can use any dependency that you want. Configuration. Now, for configuration, it's the exact same thing that you should be doing today. Infrastructure as code, using Terraform, CloudFormation, AWS SAM, or we have an open source framework, serverless framework, that you can also do this, which at the end of the day transpiles down to CloudFormation. So nothing really different here. You should be writing your infrastructure as code, so you have like sane deployments and a rollback strategy and all that good stuff. This is what the serverless.yaml configuration file looks like real quickly. Basically, I have a service. This is my user service. I just specify where I want to deploy this to. So I want to deploy this to AWS, where I want it to run, what I want to run. So this is just the function code that I want to run. And then how I actually want to trigger it. What should actually run my function code? So the event attached to the save user function is an HTTP post. So when someone hits the /save user endpoint with a post, it will then trigger my saved user function. And then likewise, down here, I have another function defined, which is make thumbnail. And I'm actually attaching this to what I described earlier, the object created event. So I can automatically trigger like thumbnail or resize functionality, which is kind of a contrived example. You can do a lot more stuff with that, but And then the other piece of that is like, so almost every real world service needs a data store or other like backing pieces like a message bus or more S3 buckets, specific IAM policies. It's a BYOC, bring your own CloudFormation. Down at the bottom of your configuration, you can define any additional resource that you may need in your service. And then at the end of the day, that gets transpiled down into CloudFormation. So even if you did want to eject and not use a framework, you could do that and just use your raw CloudFormation. This is only like probably the top 10% of what the actual CloudFormation looks like. CloudFormation is extremely verbose, extremely powerful, but extremely verbose. And that's kind of why we built the open source framework. But cool. So going to the build step. So it's the same as you would normally do, right? So you use whatever transpilation method, bundle all your dependencies together, and it's pretty much the exact same as you would today. There are some caveats. Basically, your function needs to be under 50 megabytes on like zipped up. That's probably a limit that'll be lifted shortly, but right now that's kind of the name of the game. And then 250 megabytes uncompressed. And this also, like as a pro tip, keeping your lambdas as small as possible actually minimizes the cold start time. Because when a Lambda or any function as a service spins up, it's spinning up a container, grabbing those dependencies, and then like starting the VM or the container basically. So keeping things as lean as possible, you're going to have faster functions. Cool. So testing, same as you would use whatever testing framework that you want. And yeah, we'll go into some tips on this, but it's honestly no changes there. You would run your unit tests through your CI system, then run your integration test after your infrastructure is provisioned. Yeah. And so packaging, for Lambda functions, you actually zip up the function code with all the dependencies, because you don't want your dependencies like installing like when the container spins up, because it's responding to the actual request. That would be super slow if you did that. So you package up all of your node dependencies or whatever language you're using, and that's where that 50 megabyte limit comes into play. And you can do this yourself. You can write your own bash scripts. You can, you can actually just zip it up on your machine and go through the AWS console, upload the zip. It's super easy to do with one function, but if you're building like basically a suite of microservices, which is typically what you would do as your app or company grows, that becomes an untenable solution very quickly, and you need some sort of framework. There are tons of them out there. Apex, SAM from AWS, Claudia, Sparta, Zappa, and Chalice. Those are two like Python-related ones. And we have an open source one as well. Don't have to use it. We actually don't make any money off of it. So, yeah, it's really up to you what you want to use, but use something for sure. For CI, it's the same as you would normally as well. No changes there. Use your favorite CI tool. And do your unit tests and integration tests in that flow. This is actually the deployment flow, this is running off of my local machine, but this is how it would be like in Travis, where basically I run the CLI tool. This is SLS is shorthand for serverless. Serverless deploy in my current working directory. It will then zip up all my dependencies. And then basically transpile that into CloudFormation, then pipe that up with the code into a CloudFormation stack, provision all of the resources, and return all of the live data back for me. Yeah, that's really kind of what it does in a nutshell. And yeah, this is actually an example. This is using AWS Code Pipeline, where basically, GitHub triggers the build in AWS Code Pipeline. It does all the things a normal CI system would do. And then this is actually notifying a human being, hey, that like everything passed, is this ready to go? So we use Travis internally, but there are a lot of people using Code Pipeline as well. This is a project called Lam CI. You can actually run a CI system in a Lambda function. Go figure. Again, you can do whatever you want as long as it takes under 5 minutes. This is simply the same thing, a GitHub triggering an event that goes into a Lambda function. It does the build and then updates the actual artifacts. Yeah. And then there's a project or company out there called SeedRun that you can just straight up connect your GitHub repo to it, and it will like basically provision your serverless infrastructure. Cool tool to check out at seed.run. Okay, so what about like load testing? And this is kind of to do with testing, the testing section, but basically doing load testing, if you wanted to do that, like let's say within a single EC2 instance, you can get about 300 requests per second using artillery.io, which is just like a thing to hammer a service to test that it can take the load that you want. You might be able to get a little bit more out of that if you bump up the sizes and what have you. But what about when you need like a huge number of requests very quickly? How can you do that? There's actually a project out there. All this stuff is open source, by the way. All the stuff that I'm sharing. That's not like a managed service. This is from Nordstrom. They're a retail company here in the U.S. I guess I don't have to say that in the U.S. But anyways, yeah. So yeah, so basically the idea here is you can spin up as many Lambda functions in parallel as you want. There's a hard limit, a soft limit on accounts to start off with, which is 1,000 concurrent invocations. Call your AWS rep and say, hey, I want as many as you can give me, and they say, cool, we want your money, no problem. So in this example, there's like a configuration script. Depending on how much load you want to like put on a given service, it will spin up in parallel as many workers as you need, and then hammer a system. This is also being used for like big data pipelines and stuff like that. There's a project in the Python community called PyRen that data scientists are like doing like huge MapReduce jobs on at like a fraction of the time that it would using like EC2. Cool. So monitoring is a little bit different in the serverless world. Where basically, again, most of the stuff is AWS specific, but it's very similar in all the other providers. All of the kind of AWS tools feed into a service called CloudWatch, where you can pull the logs out. You can use that as your logging system. There are some limitations. It's not as robust as other third-party systems. So what you can actually do is listen to CloudWatch logs, pipe that through a Lambda function, and then dump that into like your own Elk stack or whatever, like Datadog or whatever like kind of third-party system you're using. So yeah, and then there's a startup called IO Pipes that give you like a bunch of metrics around your actual functions that I recommend checking out. And then there's also an AWS service called Xray. This is our actual like live production system. So when you're building a distributed system, especially with like little tiny functions, and those functions are talking to databases, and those databases are doing X, Y, Z, it's like very easy for like the system to be too complex to visualize in your head. So using something like Xray that actually traces through the actual system and gives you like anything that's like performing badly. This is an example. S3 was going slow that day. But yeah, basically it'll show you the hops and where anything is like failing or where any like bottlenecks may be. This is just an SDK that you include in your function code, and then you basically get these like metrics out of the box. And we're using this in production. And then it'll give you a breakdown as well. This is actually super embarrassing. How slow this is. This is bad. Yeah. Anyways, but it gives you the breakdown of like, okay, this Lambda function is invoked. This is how long it takes, and you can kind of see where a bottleneck might be in your system. This is an anti-pattern that you should avoid of a Lambda calling a Lambda calling a Lambda calling a Lambda calling a Lambda. You want to like minimize that as much as possible and do the request in parallel if you can. And yeah, this is Jan Choi. This guy is all over Medium, all over Twitter. He's like the serverless guru. I highly recommend following this man. But he wrote a blog post on Medium about how to do distributed tracing with like correlation IDs. So like this was before Xray existed, and he basically rolled his own system. When you do add Xray, obviously it costs money to do that, because that's why else would they, they're not going to give you stuff for free usually. So definitely recommend checking this out. It's a really cool way of how he's forwarding correlation IDs in the headers of the different calls. So what about security? So with security, you want to do everything that you normally are doing if you are using AWS. Follow the principle of least privilege, use IAM users and roles, separate your passwords, rotate your keys, encrypt data at rest, have security drills, and audit and analyze your logs, etc. So nothing really different there if you are in the AWS ecosystem. What is different, you do want to use like some sort of mechanism like to scope your functions as tightly as you can, giving like, the God mode access key to your account to that Lambda function is probably a bad idea. So you can use plugins. The serverless framework is pluggable. So this is a plugin out there where basically in this function, I'm saying, hey, this handler, this function get has this custom role that only allows get item on this specific DynamoDB table in this specific region on this specific table. So like you want to start thinking in that way of how do I scope this down as tightly as possible. There's some linting tools as well. So like again, we compile everything down to CloudFormation, but basically you can use linting to see if anything is too permissive. This is a tool out there, CNF NAG. So how do you handle secrets in the serverless world? So a lot of systems out there like Console or Vault, like HashiCorp products, they don't necessarily like fit into the serverless ecosystem very well, especially like Console, which is service discovery, because that's happening at the DNS layer. You don't have that access in like the serverless world. So there's like kind of other solutions for that. But for secrets, people typically use Amazon's secure systems manager parameter store or KMS to just encrypt their secrets. You can use a third-party provider as well, but yeah. And what that kind of looks like in your configuration is right here. So I'm providing an environment variable to my function. It's just using serverless variables to call out to AWS SSM with the actual path to my secret. And like during build time, this will basically get populated. Another thing to note here is like defining like configurable regions and stages. So I can deploy this service to as many stages as I want, and that's super important for integration testing. Like we'll spin up a stack with like a random ID on it, all the different microservices in that stack, and then run testing against that. And then after it's done, tear the entire thing down. And doing that with like a single command is like ultimately very powerful. So don't hard code values in your configuration, whatever configuration you're using, because you can't automate stuff like that. You're going to run into basically like errors like this resource already exists, etc. Cool. So what about controlling costs? So this is not right. Controlling costs, there's a project out there. This is from Capital One called Cloud Custodian. This will actually like slurp in like kind of resources from your AWS account. Make sure the security policies are in check. Make sure like your tagging stuff is up to date, and make sure like any underutilized resources that like maybe you have a function that hasn't ran in like 6 months. That actually doesn't cost you anything, so that's a bad example. But like, let's say you have a EC2 instance that is being way underutilized. You can kind of like clean up that stuff. Cool. And then just some other quick use cases. How are we doing on time? Oh, I'm over? Okay. All right, I'm going to skip this. The slides are online. Yeah, use your imagination. Like you can really do anything with a serverless function. RCICD Flow, this is like our actual production system with a bunch of different microservices, with a bunch of different databases. And the way that this works is, a new branch triggers a build in Travis. First we run the unit test, then we lint, etc. Then every service is deployed to a unique stage, like stage XYZ 1, 2, 3, like randomly generated. Then after the services and resources are live, the integration tests run and make sure that everything works. If it does, then cool, we can go ahead and SLS deploy to stage of prod. But yeah, again, for this to work, don't hard code any values in your configuration. Cool, and that's pretty much it. Yeah. Any questions? There's pretty pictures at the end, but they're not important.